What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And today we are back at it with SAT review. We haven't done a video in a couple of days, but we got the test coming up in just over a week. And by the way, quick news, quick announcement. I'm taking that test, which is going to be really fun. So I'm signed up for the March 11th SAT in Los Angeles. If you guys are taking it in Los Angeles, who knows? Maybe I'll see you there. But that's going to be pretty fun. And I just wanted to also say, leading up to this test, we're going to do a ton of content. I'm still kind of planning it out. I want to do stuff for international students for the digital SAT, as well as our US students that are taking still the paper version. So we're going to have content for both, maybe even 1 to 2 videos a day. It's a really busy time of the year for me right now, so a lot of stuff going on. So I just wanted to apologize for not doing more content in the last week. Hey, you just took your SAT yesterday. Congrats. Yeah, I saw that people were taking it yesterday. But we're going to try and be as productive as possible, given, despite the fact that we got all this other things going on. By the way, I've got a huge announcement to make. Not yet, but we are so excited. Something's going down where basically something really incredible is about to happen in the world. A partnership that I've been working on for a little bit might be coming to fruition. So like I said, we'll announce it shortly, but it's going to be incredible for students everywhere. And I'm very, very excited about it. Anyways, so what's up, Alex? What's up, everybody? Thank you for joining. Let's get right down to business because I got to jump off in 14 minutes. So we're going to do a timed mini section here. Again, this is my favorite part of Khan Academy is the mini sections. So we're going to do one. We're going to jump through. I'm going to explain the problems as I go. What's up, Queen? I'm so sorry about that, to hear that it's likely to be canceled, but I got to jump right into the mix right now and jump through some problems. So we're going to keep doing it day by day, every day. If you guys like this video or enjoy it, please make sure to click that like button. If you want to see more, definitely subscribe. That'd be awesome to see you along this next week and a half journey consistently with all the good content we're going to be making. Here we go. 3, 2, oh wait, this is a calculator. Let me pull up a calculator here. We got this one. We're ready to go in 3, 2, 1. Boom. Let's make sure we got the web pane up here. All right. Let me zoom in a little more. Okay, cool. Judge's hair falls about 16 centimeters below her shoulder and grows about 5 centimeters every 4 months. So it's already at 16. And grows about 5 centimeters every 4 months. We can represent it like this. I'm just sort of putting it together as a linear equation because think about it. If you plug in, no, did I do this right? Yeah. If you plug in 4 for months, the 4s will cancel out and it'll be 5. If you plug in 8, it'll be 8 over 4, which is 2 times 5 is 10, right? So every 4 months, it's growing by 5. Josie would like to have her hair wait, let me think about this. Plan to grow her hair and donate about. So she's got 16 centimeters below her shoulder and grows 5 centimeters. And she wants it, so it's 16, grows 5, and she wants to donate 21 after her next haircut. She'd like to have her hair fall about, this is so confusing, 5 centimeters below her shoulder out of the next haircut. So basically, it's 16, and she wants to get it to 26. So then she can donate it, so then it's, so right now it's 16, then it'll be 21, then it'll be 26. Then they can take off the 21 and still have 5. So we want this to equal 26. All right. I don't know. There's my best shot at it. It's obviously they didn't use 26, so I'm pretty sure I know what they did. And the 1.25 is the same as 5/4. This doesn't make sense. So 26, let's see, 5/4. Oh, wait. It's actually equal to 10, but they don't have that option. So we have... And they have 21 on these sides. So if I minus 5, then I get 21, 16, minus 5. Or if I add 5 and minus 21, it's this one, as weird as it is. Because I wouldn't have put it together like that. But they took my equation here. This is what they did. So then when you subtract, you get 21 equals negative 5 plus 16 plus 5m over 4. This is harder than an SAT problem, by the way, so I wouldn't stress about this. But basically what they did is they swapped these. They brought the 5 over as positive 5 and the 21 over here. So C is the winner. Really hard question, in my opinion. All right, let's go. 5 minus 8x is infinitely many solutions. These have to be exactly identical, meaning C has to be -8, and the 5s are already identical. Boom, done. Number, this one, 3. An environmental biologist recorded the... Okay, let me zoom out a little bit. An environmental biologist recorded the numbers of snail eggs in the first clutch group laid different temperatures shown. Histogram left. At 22 degrees, snails laid a mean of 49. So wait, let's see. At 22 degrees... the snails laid a mean of 49 eggs. At 25, they laid a mean of 31, which even best compares standard deviations. Oh, so these are the two different temperatures. Got it. 25. I was like, wait, what? So all they're asking about standard deviation. That's it. This is going to have a greater standard deviation because it's more spread out. Very too much to have a standard valid. What? Standard deviation is greater when the first clutch is at 22. Yeah, this looks more spread out. That's all it is. This one looks more concentrated here and less spread out, less like that. Standard deviation is greater. Nope. And that's it. About the same. That's so weird. I don't like that about, but no. Okay. A company has a goal of doubling the revenue from $32 million to $64 over the next 2 years. The company increases revenue by 50% the first year. So 50% of that is 16, so it's at 48. By what percentage must the company increase their revenue by the second year in order to reach their goal? So they have to get to 64 million, so they need another 16. That's 1/3, so that's 33%. And they did say approximately. That's about a third, so they did say that. So we're good to go. 5, let's go. Okay. The scatter plot left shows the number of moose. I'm going to see if I'm not going to zoom in. The scatter plot above shows the number of moose estimated living in Minnesota from 2005 to 2012. Which following best equation models the moose in Minnesota? Let's see. So it looks roughly linear, I would say. I'm guessing. So a nice y-intercept of 9,000 approximately might be good. 10,000, But it's definitely a negative slope. These are negative. These are negative. Out, out. Okay, let's plot a couple points here. Like, if I plug in 7, no, this one's crazy. Look, if I plug in 7, I should get about 4,000. When I plug in 7 here, I'll just do it mentally. 7,000, 5,600, 12,600. So they give you a negative value, not a positive value. Here, plug in 7, that's like 35, 38. Let's say around 4,000. 85 minus 4,000 is about that. It's got to be A. We could do one other point, maybe. Let's do 1. So that'd be 8. That'd be 8,000. That matches up nicely. Boom, done. Okay, these are so long. Students in a college geography or country displaying population density per square kilometer table is only partially filled in. The frequency of countries with population density of fewer than 100 and a medium population among all countries. So it's saying this, fewer than 100 and medium population. This is not like a real SAT problem. What the heck? How many countries have both a population density of fewer than 100? So I guess we have to calculate the total, 9, 20, 23. So the population's 23. So we just take this of that. 0.174 times 23, if I'm understanding it correctly. So I guess it's 4. It's just such a weird problem. There's just like so much to read. Okay, next one. A hot air balloon reaches its maximum cruise height of 1,500. It's all word problems. 1,500 above sea level. Over the next 5 minutes, it descends at a constant rate to an altitude of 1,200 feet. So like some amount per minute to equal 1,200. If X represents time, which we already did, in minutes, boom, already set up, beautiful. After starting the initial descent, and Y represents the height. Wait. Oh, it's just this. No, wait a minute. Wait a minute. Don't be too hasty. For the next 5 minutes, it descends at a constant rate to a new cruising altitude of 1,200. And then so it would be 60 feet per minute. Not that that matters. 60 feet per minute. Wait. It's B. It's not. I did it backwards because. Oh. X represents time. Yeah, I messed it up. It's B. Woo. That was a close miss. Okay, now I'll tell you why. Look, 1 minute, whatever it is, 1440, 2 minutes, 3 minutes, 5 minutes, 5 times 60 is 300. 1500 minus 300 is 1200. So B is the answer. Oh boy. So I tried to set it up. I always try to do that. I always try and set it up. Usually it works in my favor. This time it didn't, but I caught it. Boom, done. All right. Yes. All right. Nice radical. No word problems. Trying is clearly multiplying. So check it out. I'm going to just multiply everything. Everything under the radical, they're all imprisoned together. They all interact. They all multiply. So we got the cube root of 5 times 25, 125. G to the first time, G to the fifth is G. Oops. It's a weird G. G to the sixth, F to the fourth. Okay. And then we take the cube root. That's a perfect cube. 5 comes out. G to the sixth, perfect cube. Cube root of G to the sixth is G squared, right? Because G squared cubed is G to the sixth. F fourth is really F cubed times F to the first. That's a perfect cube, comes out as F. And that lonesome F here stays trapped inside. So it is A. Nice. Next, this guy, which is an equivalent. Okay, we got a factor. Oh boy, how much time do we have? Well, actually, that time doesn't matter because I got to go in 4 minutes anyways. Okay, here we go. Let's factor the top, little leading coefficient. There is a star at the bottom. You just factor out a GCF of 4. Okay, and then this one, let's see if I can do it mentally. Hold on. Now I'm going to use the star method. Okay, so we put the A term up here. A times C is negative 48 and then negative 13. Two numbers multiply negative 48, add to negative 13. 8 and 6. No. Negative 16 and 3. Negative 16 and 3. Simplify 4 to 1. Simplify 3 to negative 4. So it's 4x plus 1. That's going to cancel out. That's nice. And then 3x minus 4 times, factor out the 4 on the other one, x plus 5. On the bottom, it's a difference of squares. Wow, this is pretty long. 3x minus 3x plus 4. And cancel. Wait, let's do it in a different color. No, it's fine. Cancel. That's all we got. And then we're left with 4x times 5, which is 4x plus 20 on the top. So it's probably C. And then on the bottom, no. And then on the bottom, oh, no. Undo. We can cancel out the 4s. All right, cancel out the 4. Boom. Then I got x plus 5 over 3x plus 4, which is A. Yes. All right, let's go. Last one is number 10. Sediment, blah, 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 instruction. Okay, the following function C gives the light intensity in candela per square meter of a light depth of d meters. Particular. Okay, is equivalent, shows the approximate percent change. Constant or coefficient percent change per centimeter. D is in meters, and they want, oh my God, that's in meters. They want it in centimeters, which means I multiply it by 100. And then it's, because I don't divide by 100. If I divide by 100, it's going the wrong way. So meters, right? 1 meter is 100. 2 meters is 200. So it's probably this one, because I don't know why there's plus or minus and shouldn't be divide. And then you do that. And then they changed it to 1 minus 0.00. Why did they do 1 minus 0.002? That doesn't make sense, right? D plus 100. Why are they adding? Because that would be 0.998. Oh boy, I'm tripping. Hold on. If you plug in 2 there, percent change per centimeter. Oh, I think it is C. No. So 1 is 100 centimeters, and then they had to modify this. It is C. Because now they're putting it in. Now this converts it to centimeters, so they had to change this. This percentage can't be the same. And so now it's like 0.0, what is it? 20%, 2%, 0.2% instead of 20%. I think that's right. Let's see. Come on. Yeah, all good. Okay, quickly, let me say what's up to everybody. And yo, got it. I'm with you. I'm going to get all of them done through the thing. And the thing is, Queen, what I'm excited about for those digital SAT videos, I'm really going to show you guys how to use the Desmos calculator. I've been using it for so many years. I was like, when I was doing it last time, I'm like, man, this is actually a far superior calculator to the TI-84 or anything else. In my opinion, it's so easy to use and it's quick. Anyways, guys, that's it. Thank you so much for joining. We're going to be banging out videos all this week. Like this video if you liked it. Click that subscribe button if you want to see more, and I will see you in the next video. Take it easy.